Welcome to today's webcast titled IoT at the Edge, Moving Towards an Equipment as a Service Business Model. Today's program will be presented by Robin Duke-Woolley, CEO of Beecham Research, and Philip Hooker, Vice President for Strategic Programs. Founder and CEO of Beecham Research Limited, Robin is a highly experienced IoT market analyst and consultant with a background of senior management in the high-tech manufacturing industry. With over 40 years of experience, Robin spent 20 of those years in industry management roles in international technology service and vendor companies, including MIS, product marketing, technical sales, commercial, and general management. Since 2001, Beecham Research has specialized in market analysis and strategy consulting in the machine-to-machine IoT connected devices market. Robin is an internationally recognized thought leader on the topic. Philip leads a range of initiatives which accelerate the corporate exploitation of cloud. He has over 25 years of experience working with the CXOs of global organizations in many sectors, including Orange, Nokia, Barclays, Wipro, and PRS for Music on numerous strategic, business development, and transformation programs. Philip is ITIL, Prince2, and MSP certified, and he also holds a Master's of Engineering in Information Engineering and an MBA from the University of Bath in the United Kingdom. As we move through today's program, we invite you to submit any questions that you have. The question box is located on the left side of the webcast dashboard. Type your question into that box and hit submit when you're ready. Should we not have time to get to your question, your submission will be noted, and one of our speakers will be back in touch with you as soon as possible. Here now to begin today's program is Robin Duke-Woolley.
Thanks, Will. That's very interesting and makes me feel soon to be old. So let's move on before we get on to that discussion. Now, to start things off, we'd like to know a bit about you, please. Before we tell you anything, we'd like to know a bit from you. So we have a poll question here, and you can then put your answers into that in your own keypad. So the first question is: at what stage is your organization in implementing IoT at the edge? Are you researching the topic? Are you planning implementation? Are you trying it out? Are you ramping it up? Or do you have several projects at different stages? So I'll just repeat that, and then we'll go to the responses. So if you can start putting your answers in now, please. At what stage is your organization at in implementing IoT at the edge? Are you researching the topic, planning implementation, trying it out, ramping it up, or several projects at different stages? So thanks very much. We'll now go and see where we've got to on that. So we have a very large number of researching the topic. And we have a few trying it out, and more ramping up, and then several projects at different stages. Phil, do you have any thoughts on that?
I think it's interesting to see how this kind of reflects the general market, I think, in this IoT edge space. So I think it's good to see. And I think from our prep, Robin, I think we've got things roughly in the sweet spot.
Yes, good. Okay, good. So a lot of research in the topic, which is very good for us because we're going to start at the right at the base of it. So that's terrific. Okay, we're now going to move over to my slides, and I'd just like to remind you, if you've not already seen it, that there is a report out, IoT Edge Enabling the Real-Time Enterprise. 116 pages. It's free to download at www.iotedge.com. Do download it if you haven't already. Some of the research I'm talking about in the next few slides are from that report. So let me move on to my first slide, which is really trying to emphasize how important being connected is compared with not being connected, where the value comes from. So in the left-hand side, we have a non-connected product, and the profits there come from the product itself. You sell the product, you make a profit from the product, and that's where it ends. And that's usually where a product manufacturer sees the last of the product as well, unless it breaks, in which case there might be some sort of maintenance agreement, but otherwise there's not much visibility of it. But then if you have a connected product, on the other hand, there's all sorts of additional activities from the services surrounding the product, knowledge, content from the about the product, and data coming from it. and consumables might be involved as well. So you get to a stage, depending on what the product is, you could get to a stage where actually the device itself becomes secondary to the value it brings to the customer. It's really all about an overall service. And that's really what we're talking about today, moving from a non-connected product to a full connected product. And in fact, we're calling it here equipment as a service, where the product itself becomes part of a managed service. So that's where we're going with this. Now, just to take that a stage further, we've done quite a bit of work in this area, and the typical layers that you go through in creating an equipment as a service package are information collection and exception reporting. So remote monitoring, that's typically where IoT and in earlier days M2M started. Then data analysis and tooling, so what can you make of the data? And then moving on to real-time decision support, and then towards real-time control. And it's not until you get to that real-time control that you're talking about a package of equipment as a service. So it's quite far up. It means that you have to go through a fair number of stages before you can get there. And also along the bottom line here, we've put in elements of recurring service. So the elements that need to be included in the overall equipment as a service package, and in fact, all of the layers leading up to that. So it could be asset management, IT support, facilities management, software support, system integration, change management, maintenance, training, and administration. And there are others as well. So really this emphasizes that moving towards equipment as a service is not like a single shot. It's not like one business unit doing it on its own. It's much more to do with the overall company and moving several elements all together into the final package. So that's what we're talking about. And just move on to some further data now. I'm going to talk a little bit here about the definition of edge, because edge is not just edge. There's lots of layers of edge, and people have been talking about edge for some time, but what do they actually mean by that? Well, we've got basically looking at from the right-hand side, we have a centralized data centers in a network, which is near edge, and then we have a service provider edge, which is far edge, and then we have the user edge, which is right at the on the left-hand side. We have a constrained device edge, which is also known as thin edge, and we have on-prem data center edge, which is often referred to as thick edge. So when we talk about edge, there are different edges that we mean for different points of view and different requirements. If you're looking at it from a mobile operator perspective, for example, then you'd have the centralized data centers, and then you'd have the regional edge, which is like having some sort of database or some sort of data center at like cell towers. So it's fairly far out in the network, and that then reduces the latency to get to the end device at the end of the network. And that's what it's all about, is to provide lower latency services for a large number of devices out in the field. And then if you're talking about the end device itself, we have a constrained device edge, which would be something like something that's battery operated or something like that. It could be a wide range of different alternatives there. And there is a need to provide processing at that remote corner in case there is no connectivity for one reason or another. So, yeah, as I say, there are different definitions of edge depending on what you are involved with. And for this exercise, we're interested in thin edge primarily and also thick edge, but so primarily in thin edge. So having clarified that, I'll then move on. So one of the survey results that we had, which I think is really quite interesting, is looking at the benefits of edge implementation. And this is from a large number of executives. And the most important value was, in fact, seen to be security compliance, which is perhaps counterintuitive. You might think that if you move things out to the edge, they might be less secure. But because you have more control over them, you have more opportunity to maintain security over them. And then there's the opportunity also for obeying local regulations and things like that on security and compliance and so forth, which also makes it easier to control. And then there's operational efficiency. So there's the activities, for example, in a factory, and the opportunities for improving the efficiency of that. There's application performance and improving that application performance. There's also customer experience. If you push things out to the edge, then you get a more immediate response for customers, and that also helps. And then productivity through automation and faster, better decisions. In other words, there are quite a lot of benefits that come from moving things out to the edge. And then we've conducted a whole range of one-on-one interviews with people in the industry. And I just wanted to summarize some of those findings. So we had key benefits of edge versus cloud. And here, the first one is taking a load off your cloud and off your network, because you're taking it to a local process. And basically, that's saving cost. It's a cost benefit for doing that. This is headed edge versus cloud. We would say that it's not really a question of edge instead of cloud or edge replacing cloud. It's both of them working together. It's important here, and we'll get on to discuss that a little bit later. But it's one of the benefits of at the edge versus operating things at the cloud. But it's all part of where you draw the balance between two. And the second then is ease of deployment. The IT-OT merging tends to happen as part of the edge. So there is an ease of deployment for that. And then the third quote on this page is looking at integrating AI, artificial intelligence, into products. Helps to make them smarter, reduce energy consumption, things like that. So that's some benefits in doing that. These are all, of course, only examples of what's going on. It's what people have told us in the field when we've interviewed them. And these interviews were conducted really quite recently. It's not something that was conducted years ago. It's like within the last certainly 6 months. So the next one is IoT edge drivers and trends. Now, this is all about reducing costs. Do you really want to stream data to the cloud because there is a cost? If you could process all that data locally and only stream the valuable data that reduces costs. But I think the biggest driver that we're seeing is security. Well, that's back to the survey that I showed a little bit earlier on. So a very strong feeling that security is a big plus from edge. And then the next one, the most prevalent trend is in reducing latencies. You reduce your latency just by having computing and data physically closer to users. One of the main things for introducing 5G, of course, is to reduce latency, and edge is an intrinsic part of the introduction of 5G and how latency is provided as part of that. So we're going to see a lot more edge over the next few years. And then the third one is we're seeing growth in 3 areas. Industrial automation use cases are growing fast. how to be more productive with less resources. Building automation, companies that manage buildings are trying to figure out ways to save energy. And the retail space, companies are looking at the point of sale and how to prevent theft, fraud, and so forth, to see if customer baskets match their receipts and so forth, things like that. So that's that one. And then we have a third area. So which use cases are developing fastest? Quite an interesting question. And some of the responses that came back were we see hospitals implementing our solutions that allow real-time image processing for disease detection. Also, emergency medical use cases can leverage edge computing, and data can be transmitted in near real time from ambulance to hospital. And then continued development of automation in dangerous and remote environments. And then also traditional use cases are isolated on-site solutions, but arrays of distributed processing solutions are mushrooming. So this is a technical response from a technical person, and it's really looking at how single use is developing into distributed processing use in many different areas. So those are examples of some of the interview responses that we had. As I say, in the report that I pointed out, there are quite a few more. Then we wanted to look at the actual implementation in a survey. So here is a typical response on IoT technology adoption. And for this particular survey, which was conducted in 2020 for results in 2020, and it was reported in 2021, so it's pretty up to date. 47% were deploying IoT solutions today. 30 that's edge solutions, that is. 39% deploying in the next 24 months, and then 14% no plans to deploy. So that's a lot. That's a lot of movement towards IoT at the edge happening right now. And then in terms of investment, again, this is investment at the point of the end of 2020. So 54% were spending up to 100K or $100K dollars, or had invested up to $100K. 30% had invested between 100K and $1 million, which was ×2 on the 2019 results. So there's a big increase in that area over the 2019 numbers. And then 16% over $1 million, which is 25% up on 2019. So this gives an indication that people who had invested earlier are beginning to move forward with their investments, sort of up to 100 to $1 million. And then a few of the 100K to $1 million are moving beyond that to over $1 million. So it's the investment is going in a wave, and it's beginning to really start to take off now. And then a further survey. This was originally a survey actually by IBM of 50 across 22 countries and 21 countries. So we're focusing on responses. So 81% of executives involved in their organization's edge computing strategies expect edge applications to improve operational responsiveness in the next 5 years. So they're really expecting, the vast majority expecting huge change towards edge within the next 5 years. 94% say their organizations will implement edge computing in the next 5 years. And the sort of average ROI that they're expecting is 23% within 3 years, compared with 3% for their peers. So they're expecting a high return on investment, and they're expecting to do it pretty quickly. So that was the outtake from that survey. So I have one more slide, which is really looking at a previous project that we looked at, why IoT projects fail. And it's not to look at projects because we like them to fail. It's actually because we look at projects because we like them not to fail. But we think that people can learn an awful lot from seeing where projects have failed in the past. And I just wanted to point out two particular questions that came up in the surveys that we did. How important were these project objectives? So we have improved productivity and efficiency, reducing costs, driving revenues, enabling new business models, increasing safety and security, and data and asset utilization. And you'll see that enabling new business models, 63% reckoned that it's very important. And then a further 31% reckoned it was important. And only 6% reckoned it was not important. So developing a new business model is considered often to be a very important part of introducing IoT. But when you look at the actual results that we measured, to what extent were these objectives achieved? If you look at enabling new business models, you see that only 4% was successful, very successful. 43% were partially successful, but a really rather high 63%, 53% were not successful at all. So basically, I mean, that points out the issue that we've got here that we're going to be now expanding in this discussion, is that enabling new business models through IoT is a highly desirable thing to do, but not often successful. And Phil is now going to outline how to make it easier to implement and faster to implement and potentially more successful as a result. So Phil, I'm going to hand it over to you and take it away.
Excellent. Thanks, Robin. So as Robin's outlined, so delivering equipment as a service is becoming the desired vision for many enterprises. But there are many challenges to actually achieve this. And I would like to show in this quick slides and kind of other content is actually just how the IoT edge is becoming a foundation technology of delivering equipment as a service. Perhaps the best way to do this is actually to just show it in action. I'll show you what equipment as a service is. So one example is actually, we worked with DMG Mori. So they're a global manufacturer of automated high-performance, high-efficiency CNC machine tools that are used in a wide range of industries, including automotive, aerospace, and medical. They realized that quality alone is no longer a prerequisite for competitive success, and a different approach is required to satisfy the customer's requirements.
Especially startups and businesses with lower budgets have to find creative ways to be able to compete and stay on top of their game. Hazer helps me to stay flexible and productive and ensures that I stay in control over my company's resources. How does it work? Fair, transparent, and simple. I only pay a small monthly fee and a rate per spindle hour. I simply choose the duration of the Pazer contract term and configure the M1 to correspond with my needs. The fixed monthly fee includes an all-around carefree package. After a quick credit and identity check, the order is placed. Once that's done, DMG Mori directly coordinates the delivery date with me. In order to stay in full control, my DMG Mori provides me with essential information such as the machine status and spindle hours. And the M1 is only the beginning. Soon I'll be able to order many more machines with Pazer. M1, designed for your profit.
Excellent. So with Pazer, DMG Mori offers a business model that allows customers risk-free use based on the equipment as a service model. So subscription instead of ownership, with planning security and cost transparency, financial flexibility with no investment risk, and flexible operating expenses based on the spindle hours themselves, plus also a digital point of sale. DMG Mori has actually expanded the Pazer portfolio, and in September last year added the new CLX 450 automated milling machine to the roster. So, as shown in the DMG Mori example, the equipment as a service approach provides considerable benefits to both buyers and suppliers. IoT Analytics and Bain found that customers preferred the reduced capex and the transfer of maintenance responsibility to the supplier. Lower cost of ownership through only paying for usage and outcomes. the increased flexibility, allowing customers to scale their operations up or down to meet their demands. Through although disruptive to current approaches, especially for kind of suppliers with the large distribution chains kind of following a unit-based model, equipment as a service is also found to provide many benefits to the suppliers themselves, so reducing barriers to adoption for new customers, and also improving customer retention through creating stickier long-term relationships. Also improving margins through increasing the profitable after-sales services and parts revenues, and also avoiding the downsides related to increased asset utilization. And obviously what's important at the moment with kind of all the ESG topics, actually reducing the environmental impact through prolonging equipment lifetimes and improving reuse to lower CO2 emissions and fostering a circular economy. So with these benefits, it's no wonder that almost 2/3 of suppliers are actually found to be evaluating, planning, or offering equipment as a service propositions at the moment. And with that, 6.7% of all industrial equipment is forecast to be sold as equipment service by 2025. But with all these benefits as everything, there's always a balance, yeah? So the journey towards the equipment as a service has a number of challenges, as indicated here, related to business, related to technologies, kind of Robin's indicated previously. So on the business side, pricing equipment as service agreements is difficult, especially for suppliers that I mentioned that are more experienced in creating unit-based agreements, as there's now a need to define and measure value. The move to equipment as service requires a transition from an existing business model with complexities associated with the distributor relationships, and also the recognition of the fish model for equipment as a service. So you have a lower initial revenue and high costs associated with the transition. Also, financing is an inherent part of equipment as a service, and suppliers need to create more sophisticated relationships with finance institutions to potentially offer a range of agreements for their customers. On the technology side, sophisticated analytics integrated with field service and spare parts management processes are required to ensure cost-efficient operation. Additional business-related metrics need to be created to generate irrefutable equipment usage statistics, and also new automated billing and payment processes are required for more frequent and lower value amounts. Equipment as a service suppliers need to assume several operational risks previously associated with their customer. Environmental factors such as temperature, dust, and vibration, which negatively impact the performance, now need to be managed and assessed. So one of the benefits, well, obviously we're talking about here, is actually IoT Edge can help overcome some of these challenges. So predictive analytics on high-frequency measurements can detect failure trends. Business-related equipment usage statistics can be generated from either new or currently logged events and securely transferred for billing. Continuous risk assessment algorithms can be executed locally and incorporate additional internal and external environmental measures. And equipment usage profiles can be created from the usage metrics and exported to identify key points of customer value and evolve pricing models. In addition to these specific equipment as a service challenges, IoT Edge overcomes typical industrial IoT challenges in a number of ways, as Robin's kind of indicated before. And I've kind of scattered sort of maybe the 6 top ones kind of around here as well. So real-time actions are essential to avoid machine downtime, higher repair costs, and poor product quality. IoT Edge can deliver low network latency and fast response times, a critical advantage when dealing with high-value assets where every minute of downtime is extremely costly. And with connectivity assurance, predictable monitoring is required to ensure that the decisions taken to control critical industrial equipment are based on reliable stream of measurements, regardless of connectivity issues. Now, IoT Edge can assure the stream of measurements is transferred regardless of connectivity bandwidth, essentially kind of bulking up and sending those later, and avoid issues of intermittent dropouts. With security, equipment used in used for critical infrastructure, like electricity grids or medical facilities or government facilities, are prohibited from transferring data to public cloud infrastructure or over insecure networks. Being completely self-contained, communication network agnostic, and deployable standalone, the best IoT edges offer computing capabilities that can be easily deployed into secure environments. Some geographic locations are only accessible via expensive low bandwidth connections, which can make remote monitoring extremely cost prohibitive. IoT Edge can pre-process measurements prior to transmission to significantly reduce the transferred data. Periodically send in process metrics or metadata, and only send in the raw data when it's essential. Autonomy is also essential. So highly reliable systems require the full sense, decide, and act control process to be conducted locally without any dependency on external systems. The best IoT edges are available as complete, fully autonomous packages that are easy to deploy and contain sophisticated analytics that can be used by field engineers without data science training. And lastly, what's kind of growing increasingly important is regarding anomaly detection, understanding how things work and how things are changing. So indicators from potential future problems are often hidden by the massive amounts of measurements generated by today's industrial assets. Using IoT Edge, machine learning models can be deployed to continuously analyze measurements for failure fingerprints, assess trends, and capture operational outliers. We believe that exploiting the potential of IoT should be simple and fast for all. Our Cumulocity IoT platform helps industrial manufacturers to transform into service companies offering as-a-service propositions by enabling their domain experts to rapidly deliver business outcomes using self-service tools. The platform's capabilities include device management, enterprise integration, and the full range of analytics, including condition monitoring, real-time stream analytics, machine learning, model management, data lake integration, and it's used by customers like Stanley Black & Decker, Eppendorf, Lyrico, and DMG Mori, as we said before. It is fully distributed and can be deployed on cloud, core, and at the edge. With our recent open source Thin-Edge.io initiative, extended the management of analytics models, OT protocol adapters, and the IoT apps out into the resource-restricted IoT Edge devices. So, as Robin indicated, so there's this kind of, we'll call it like a continuum of capabilities actually deployed across the edge. And when you consider your IoT solution, it's actually beneficial to contemplate how these edge components, these cloud components, work together. We have a number of assets across this estate. So starting with those of the clouds, the Cumulocity IoT Cloud provides an extensible, scalable, and robust carrier-grade device management and application enablement platform, suitable for efficiently managing the full device cycle of large-scale deployments. Its pre-packaged, cloud-native, and cloud-agnostic architecture allows it to be easily deployed across hybrid cloud environments. Its multi-tenancy and white-label capabilities make it directly suitable for the growing number of B2B2X offerings where end customer data, security, and rebranding are essential, like the case we saw before. Cumulocity IoT Edge, our thick edge product, as kind of Robin indicated previously, is a single server variant of the Cloud Edition, which is typically deployed on industrial PCs close to the equipment being managed for high frequency monitoring with sophisticated analytics. It shares the same APIs and architecture as a cloud variant. So all the user interfaces, analytics, models, microservice apps, protocol adapters, and integrations built in the cloud can be deployed at the edge, significantly simplifying the management of the software development lifecycle whilst also speeding innovation. Cumulocity IoT Edge can itself be managed by a cloud variant, so it can take advantage of its comprehensive software management and efficient data sharing. Thin-Edge is the extension of the Cumulocity IoT product family that simplifies onboarding and enablement of devices, and is an enterprise-grade variant of the open-source Thin-Edge.io framework for lightweight devices. It allows organizations to deliver edge use cases that need to operate within the constraints of a small memory footprint, low compute power, and anticipated issues connecting to the cloud. Thin-Edge not only increases the speed and flexibility of organizations implementing IoT projects at the edge, but enables them to leverage Cumulocity IoT's leading device management features on a broad range of devices like programmable logic controllers, protocol gateways, and devices using Linux-based operating systems. Its built-in PKI certificate management and programming language agnostic approach solves two of the key issues when creating connected products: strong digital security and efficient software lifecycle management. And perhaps lastly, our device agents, SDKs, and open APIs cater for the heterogeneous range of very low compute power devices, typically based on microcontrollers. These allow developers competent in technologies like C++, Java, and Python to REST, MQTT, and Node.js to use the device integration technologies best suited for their IoT project. To make IoT fast and simple and resilient for all, our products allow customers to develop their IoT apps, analytics models, and protocol adapters once and deploy them across the cloud, core, and edges, reducing the management overheads in software, analytics development, and accelerating competitive innovation. So from our experiences, enterprises follow a phased approach in their transition delivering equipment as a service that starts with the equipment not being connected, adding remote monitoring, providing digital services before equipment as a service itself, as in a similar analogy to what Robin actually indicated at the very start. Now I'd like to quickly outline where two customers are on their journey towards equipment as a service. So AutoSen is a subsidiary of IFM, a global leader in sensing, controlling, and automation technology, and one of the pioneers of Industry 4.0 and digital industry. AutoSen's IoT provides a way to easily monitor, manage, and analyze sensor data online. With IoT, the readings from over 10,000 sensors from more than 200 manufacturers are visible in the cloud in less than 1 minute. The solution consists of an IO-Link cellular gateway, cloud app, and Europe-wide flat data. For the industrial instrumentation market, this user-centric, online shop-initiated plug-and-play approach is highly disruptive and is extremely attractive to small, medium, and large-sized organizations, which are focused on achieving the business outcome in the shortest possible time. Each customer has its own secure tenant on Cumulocity IoT. As soon as a sensor is connected to the device, Cumulocity IoT retrieves its IO-Link configuration file, automatically updates the device to correctly interpret the sensor data, and creates a new dashboard specifically related to the measurement type, delivering remote monitoring made easy. Dürr is one of the world's leading mechanical and plant engineering companies and is a founding member of ADAMOS, the Alliance of Machine Builders for Machine Builders. By using self-service industrial analytics at the edge, Dürr's automotive customers, like Volkswagen and Audi, increase quality while decreasing paint consumption by 50% in their robotic paint stations. Based on Cumulocity IoT, Dürr has developed an equipment analytics application that runs on an industrial PC at the edge that continuously assesses the 2 gigabytes of measurements per robot per day for quality control. Paint shop engineers are able to quickly and efficiently create their own analytics algorithms using the analytics builder without any programming skills or data science knowledge, allowing them to assure production and rapidly evolving models to predict and avoid errors from robot movement, paint flow, station configuration, and more, delivering efficiency and quality in the paint application. So thanks a lot for listening, and
Great.
Any questions?
Yeah, well, I'll start with one to you, actually, Phil. Just taking those cases that you've just talked about, how long does it take to implement, and what internal resources are usually required? Can you give us an idea on that?
Yeah, so perhaps taking those two examples I kind of went through is kind of AutoSen, and so quite nicely they've got two different approaches and two different scopes. So AutoSen was one of the first major developments from this new startup and subsidiary of IFM, this larger company. So they weren't constrained by any kind of organizational constraints and process and there's logic behind that. So with that project, we aided with the configuration of the dashboards, the integration of their billing systems and their ordering systems, and the AutoSen team kind of managed the responsibility of actually developing the IoT gateway, the online shop, and the business process behind that. So the resources that were needed between the two. So for AutoSen, so there was a large percentage of time related to the representative from product management, marketing, and sort of IT during this sort of basically a sort of 6 month delivery period from when we actually started to speak to them to when that product came available. However, the development of the actual physical device itself was actually in parallel to that. So that took a bit longer, but in terms of the overall solution, that sort of took roughly that sort of 6 week period involving product management, marketing, and IT from their side.
Right.
Then think about the thing about DUR. So DUR was quite interesting because it's a different approach. So we co-innovated the self-service industrial analytics with DUR. So this took a number of quarters because the capability we built then became a core component of the Cumulocity IoT platform that could be reused by other customers. So the evolution of that capability took a couple of quarters, but then that was actually done in parallel with the delivery of obviously the business components related to DUR actually selling the service. So the service was actually only sold a couple of weeks after that capability is available, and then from DUR's side, once again, kind of not so heavy involvement because it was actually kind of a longer period of time, but involvement to the product management, the operational engineering. So the users who would use this capability and understand the analytics models and mechanisms, plus also some of their technical sales teams who are actually in discussion with the customer to actually understand what the requirements were for this particular capability.
Great. Okay.
So Robin, that kind of makes me think about a question also. So there's so we've talked about these kind of differences of edges and things. So so you define different types of edge. So there's kind of a edge this kind of edge can almost provides this merge between OT and IT. So what do you see with edge? What do you see is the difference now, and how significant do you see thin edge as being in the future?
Yeah, well, so that's a good point. I mean, looking at the OT world, they've been doing things at the edge forever. So edge itself is not new. They've been using microcomputers and so forth at the edge for a very long time. But what is new is combining edge with cloud, and also the newer technologies where you got lots more software, which is combining activities at the edge and cloud. In other words, we're using the same software components both at the edge and in the cloud, cloud native. Means that it's very much quicker and cheaper to implement. But you've also got this edge and cloud thing going on together, and that's new. And here you can visualize it as being you have the immediate control at the edge, but you have the overall view in the cloud. So if you're running a factory, you can run the machines on the one hand, but you can also see how those machines are coordinated with all the other ones in the factory in the cloud. So you've got the edge and cloud, and we put the whole picture together, and that is new, and that's driving a significant change in the IT-OT merging, which has of course been the battleground, if you like, between the different ways of looking at the manufacturing environment in particular for many years. So yeah, moving on. I'm going to ask you a question then. Going back to those case studies, as time to value or return on investment is top of mind, how quickly can your customers expect to start seeing a financial return? Is that something that takes a long time, or is it in stages, or what?
Yeah, so I like the survey you were showing before, Robert, about the sort of different sort of times and times to get responses back. So I mean, immediately kind of think about AutoSen. So AutoSen's disrupting the industrial instrumentation market. So previously it cost about 2,000 euros to deploy a new industrial sensor. Yeah, so you need to get people into the building. It takes a fair amount of time to do different things. So they're now selling services that are 10 times more efficient. So rather than this €2,000 per sensor, now it's kind of roughly kind of what sensed data, I should say. Now it's roughly kind of a couple of hundred euros per sense data, and also they're now the end customer's now getting that in minutes rather than days, or kind of potentially a week. So the end customer seeing a massive benefit, reducing the cost of sensing technologies, plus also it's faster, it's easier. For AutoSen itself, so they sell the sensors, and they also sell this IoT gateway. So what they've done is they recognize that selling sensors is kind of okay, but selling a gateway means it's far easier for organizations to leverage that sensed metric. So you can get alerts and alarms on that. So I think at the moment there's kind of, it's roughly, so how fast do they receive the benefits? I believe this is probably started to receive this within a quarter, but now over 3 years, it's looking to be kind of hundreds of millions of euros that they're gaining in incremental revenues that they wouldn't have had previously, that are actually pulling through additional sensor sales. So that's right. One. I mean, to quick another case. So with DER, obviously once again the customer mentioned before this at 50% sort of cost saving of paint, and what for them they already had this technology being used to monitor the paint station robots. This is a new capability built on top to allow additional metrics and quality control for their customer, like Volkswagen and Audi. So they've actually now kind of started a completely new kind of a business line generating millions of euros sort of straight after that availability. And then kind of going back to the DMG Mori with its software as a service capability, we talked about the benefits for the end customer, so a lower TCO, etc. And in reality, we're only going to see that once we come out of this fish curve. So kind of the end of kind of 2-3 years, when these kind of contracts come towards their end, then we start to see the benefits, the greater benefit for DMG Mori, but also immediately we see the benefits for the end customer. Okay, that's great. Good. So and then so Robin, so then thinking about kind of going back to these kind of points regarding kind of billing, etc. And I know we had a conversation before about the need to get kind of irrefutable data metrics out of devices. So one of those key aspects is security. It's kind of sort of key in IoT overall. So what aspects of IoT security are you seeing that enterprises are most concerned about, and how has this changed over the last couple of years?
Okay, well, that's quite interesting. We do surveys all the time in this area, and most recent survey shows that roughly 8% is a priority over the last 18 months. So it's much more top of mind than it was before. It's been becoming increasingly important, but it's now seen as like vital, and it's partly to do with IoT becoming more mission critical. So if there is a hack now, it's much more dangerous to an organization than it was before, and that's going to become increasingly the point. IoT is becoming a more attractive target to hack. There's more use of IoT, and there's more mission critical applications, so there's more potential for things to go wrong, if you like, as a consequence. And there's been lots of distributed working and the pandemic over the last couple of years, and that's increased the likelihood of hacks and so forth. In fact, there's a statistic that I remember from Kaspersky, which is that over the first 6 months of 2021, obviously it goes back a little bit, there were 1.5 billion hacks or attempted hacks of IoT devices, wow. Which is a lot. It's an awful lot. So I think that people now need to think about the consequences of security and security breaches much more than they have in the past. And it's not just the things go wrong. It's It's the potential loss of vulnerable, valuable data. It's the cost of fixing vulnerabilities. It's the damaged reputation that results from that. It's potential loss of customers. Might have to pay back customers for things that have gone wrong. There might be some government fines as well now. So it's all a case of there's a growing cost. But on the other side, there's also some benefits. What we're seeing now is people are beginning to trust more products that have inbuilt security. So there's a value there that perhaps hasn't been noticed before. We've always talked about security being a cost, but actually there is a benefit to it as well. And there's increased value is beginning to be perceived in the marketplace as well, which is really good. But I think the thing that I would leave us there with is that for the enterprise that has an IoT solution, and particularly ones that are becoming more complex and more mission critical, it's no longer a case of might be had. It's going to be had. And it's really just it's a matter of what are the consequences of that, and how do you minimize that by planning ahead. So that's perhaps something to think about. I think perhaps we ought to. We're going to be running out of time shortly. We need to move over to a general Q&A with Will. Will, I think you're going to conduct another quick poll, perhaps.
Yeah, Robin, thank you. We do have a bunch of questions that have come in, so we're going to start to get to those, but we would also like everybody, if you wouldn't mind, very quickly give us your feedback from the below list. What is the most important to you in an IoT platform for your role or line of work currently? And please select everything that applies. We'll give you a couple seconds there. Gentlemen, while those questions are starting to come in, I'm going to go right to the very top. The first question, security of the OT data might be constrained if OEM equipment is used as a service model. What are the possible confidence levels OEM to provide to clients?
So,
I like that. So fast ROI is 71%. So that shows that the question that I asked was actually pretty relevant. That people are very interested in a fast ROI, and also interested in scalability and how you move it from being like a concept to a full-scale project. So I think that's very interesting as well. Well, what do you think, Phil?
Well, I know both scalability and ROI are kind of key topics from a number of cases. So typically, it's actually kind of going back to some of the previous reports, Robin. So regarding why IoT projects fail, it's actually you need a business case before you start, and then once you've started, you want to sort of scale that project as fast as possible. So it nicely relates back to some of the findings we found before. So that's good. So I must admit, I've been sort of thinking in the background about
your answer to the question.
Well, yeah, I've been thinking background about this question. So it's if I understood it correctly, I think in the case where you have a difference between the customer and end customer, yeah, so your B2B to X model. So in your B2B to X model, perhaps you're providing the equipment itself is actually, maybe the equipment is a bakery machine. This providing then being deployed into a bakery, which is then actually baking bread under a secret recipe, or maybe drinks under a secret recipe or something else. So in that context, you need to ensure that the metrics you get back from that machine as it's being operated relate to the performance of the machine, not related back to the knowledge of the recipe or how it's being deployed or something else. So we've worked with a number of projects that are very similar to that. So this bakery one is directly relevant. So there's a way to separate the data within the device. So only the metrics that using kind of IoT Edge, that only the metrics that relate back to its operational performance and therefore the assurance of its performance can be retrieved, and also all the metrics related to the recipe, its ingredients, its kind of operation could actually be maintained on that device. And that's one of the key things of actually having analytics and separating that data actually on the device itself. if that answers the question. Maybe Robin, I don't know if you have any other points.
No,
on that
I think that's fine. We ought to go on to another one, actually. Yeah.
Yep.
Very good. The next one that I have for you both. Do you have a multi-tenancy feature?
That's very quick. So yes, and we'd be keen to talk to you about that if you so desire.
Very good. Moving on. Do you have an API to programmatically create assets, users, etc.?
So the platform itself can actually create the assets, like the digital twins. There's a CLI tool to create it. There's API to create it. All the APIs are open. So essentially, the answer is yes. Obviously, the devil's in the detail, but I think we'll be keen to discuss that. Yep.
What is the trend at which the industries are moving towards low-code, no-code solutions, and what is the roadmap towards promoting the adoption of this approach?
That's definitely one for you, Phil.
So what we see here is there's a let's say a move of the masses. Yeah. So there have always been pioneers who've done specific coding, whether it's on analytics or whether it's on a particular sort of code types of sophisticated products. So that the pioneers, they would all do some level of coding, but the masses are now adopting the technology because it's easy for them to use and deploy and maintain and manage. So what are we seeing regarding this trend? We're seeing that the mass adoption of kind of IoT and all its variations is through self-service tooling. So self-service is a inherent component, as we said, through all of our capabilities, and typically with the Software AG, with Cumulocity IoT, it's a pre-packaged platform that just needs to be configured. So we kind of run at this, let's say 80-20 rule. So other IoT platform, 80% is pretty much kind of built that comes to you, and you just need to do kind of 10 to 20% of configuration on top to get it to what you need to do. You don't need to stick it all together like Lego bricks. You just need to kind of polish it up. However, that whole pre-packaged solution can be kind of built out and sort of bits cut out and bits changed. So we kind of aid a lot of these industrial companies to leapfrog their competitors by adopting this kind of 80-20 model with kind of self-service tooling. What's on our roadmap? So everything is becoming self-service, and everything is aimed to be self-service at the moment. And once again, we're keen to have a conversation about that.
The next question: how viable would micro edge as a service be? Or would that primarily be provided as an off-the-shelf item and the value added upstream?
So typically, the as-a-service model is used for, initially been used for large value assets. So I think with a micro edge as a service, as a capability, would obviously go towards, rather than a single high value asset, there'd be many, many low value assets. So this could be price tags or updatable price tags in a retail store or something similar. So a lot of those are starting to become as a service at the moment. So you buy a capability, you have a range of assets you can deploy in a retail store, and then you can actually make it work that way. So would they become an off-the-shelf item? So for our customers, they're already offering that. So I know of one today, but we can't announce it today. They're already offering that kind of micro edge as a service. And I'm aware, Will, we're kind of getting close to our time here. So I'm
going to push past the time and see if we can get a couple more questions, if that's okay. What types of companies are part of ThinEdge's ecosystem?
Excellent question. So we have, if I can remember off the top of my head, so we have IFM, who's a sensor company, kind of heavily focused in the OT area. They've got massive experience in actually connecting industrial equipment. We have Nexus, who are heavily involved in security, so cybersecurity, PKI, and as everyone probably knows, PKI is an interesting term, but it's very easy to implement PKI wrong and in an industrial IoT sense. So they've got experience of actually how to make this work. We've got Initum, who are who are a kind of service provider, kind of sort of supporting assistance in different ways, as well as brain boxes and Kunbus are kind of hardware manufacturers, plus also Adamos, who's a kind of industrial manufacturer. So we're building up this ecosystem of partners who've got different perspectives on Finish.io, and they all realize that what they need is a cloud agnostic way to provide secure connectivity from resource restricted devices up to a cloud platform, any cloud platform, and also perform device management on that asset. So obviously we've kind of the contributors that have built that in, plus also we've kind of extended to allow it to make the whole software development lifecycle easier and faster for those edge products, primarily because the industrial manufacturers of that equipment aren't used to managing software in life. So they typically deploy the software once, they ship it out, and then maybe once a year, once every 2 years, their service technician would go out and actually change the software. But now you have laws and rules and regulations like in Germany where you have to maintain that software in life for security patches. So by providing sort of ThinEdge.io, you have the secure connectivity, you have the device management, plus also you have mechanisms to make managing your software in those assets far easier and far cheaper and far more efficient.